everyone, I'm going to be going over the Energy and Atmosphere Prerequisite 2, Minimum Energy Performance, and Credit 2, Optimize Energy Performance. Quickly, some abbreviations and words that you'll need to know. The ANSI ASHRAE IESNA Standard 90.1-2010 is used as a reference for both the prerequisite and credit, and here are what those abbreviations stand for. Some good words to know is the baseline building performance. That's the annual energy cost for a building design, and it's used as a baseline to compare to other models. And the energy use intensity, or EUI, is the annual energy use per square foot of a property. This prerequisite applies to all of the construction categories, so new construction, core and shell, schools, retail, data centers, warehouses and distribution centers, hospitality, and healthcare. And just remember that a prerequisite is a requirement for future related credits, but it does not earn you any points. The intent of this prerequisite is to reduce the environmental and economic harms of excessive energy use by achieving a minimum level of energy efficiency for the building and its systems. So this means that we want to run the building at a certain level of efficiency to reduce any harmful effects of excessive energy. There are three options to fulfill this prerequisite. All three options require that you be in compliance with the mandatory provisions of the Standard 90.1-2010. And if you are not in the US, then a US GBC approved equivalent can be used instead of this standard. But just remember that that will be a requirement in all of the three different options listed here. Option 1 is for all categories except healthcare and its whole building energy simulation. The proposed design must be inclusive of all energy consumption and costs within and associated with the building project, and compare against a baseline model that complies with the Standard 90.1-2010. Any unregulated load should be modeled accurately to reflect the actual expected energy consumption of the building, and the energy modeling input assumptions need to be documented. You need to demonstrate an improvement of 5% for new construction, 3% for major renovations, or 2% for core and shell projects in the proposed building performance rating as compared to that baseline building performance rating. The baseline building performance rating is calculated according to Standard 90.1-2010, Appendix G, using a simulation model. And as a side note, projects must meet the minimum percentage savings before taking credit for the renewable energy systems. And also another side note is that data centers have their own criteria for option 1. The second option is to be in prescriptive compliance with the ASHRAE 50% Advanced Energy Design Guides. You must also comply with HVAC and service water heating requirements, including equipment efficiency, economizers, ventilation, and ducts and dampers, as listed in the Design Strategies and Recommendations by Climate Zone, which is Chapter 4 of the appropriate ASHRAE 50% AEDG and Climate Zone. The appropriate guide is based off the building type and is shown here, so you can have office buildings smaller than 100,000 square feet, retail buildings with 20,000 to 100,000 square feet, K-12 school buildings, or large hospitals which are over 100,000 square feet. Those are the only building types that qualify for this option. There is a third option, but healthcare, warehouses, laboratory projects, or projects greater than 100,000 square feet are ineligible. This option requires prescriptive compliance with the Advanced Buildings Core Performance Guide. You must comply with Section 1, Section 2, and Sections 3.5 and 3.9 and 3.10. And if any of these standards conflict between any of these sections or between the Standard 90.1-2010, you need to follow the more stringent of the two. For guidance in this prerequisite, you should first determine what climate zone the project is in, and then review the Standard 90.1-2010 requirements, where sections 5.4, 6.4, 7.4, 8.4, 9.4, and 10.4 are all going to be particularly helpful and need to be followed. Then you'll need to come up with a target energy use for the building and determine whether to follow options 1, 2, or 3. If you choose to follow option 3, the target energy use should be found using the Energy Stars target finder, and the score should be greater than 90. Here's a helpful figure that shows how to choose which option. Option 1 is the mandatory option that must be followed unless you meet the certain requirements to follow the other two different options. If you plan to pursue option 1, here are some helpful guidance steps. Of course, you're going to want to review the prerequisite requirements that we've been discussing and will continue to discuss, but you're also going to want to review the credit, the optimized energy performance, those requirements, and then you need to identify an energy modeler and select it to perform the energy analysis. Next, you're going to want to create a preliminary model using the rough design of the building to analyze the design configuration. The lead reference guide said that this isn't required yet, but it's going to be quite helpful if you do it now, because it's also going to be required later on, especially if you pursue the credit. Step 4 is to analyze the performance of the HVAC system using the energy model. A baseline energy model also needs to be created to compare to this preliminary model that you develop. This can be done by referring to Appendix G of the standard, as we mentioned earlier. As the project progresses and comes into its final stages, both the baseline and preliminary models need to be updated with any final construction details and specifications. And then after this is completed, the final energy cost can be determined. You need to keep in mind that if you have any on-site renewable energy systems, they do not offset energy costs in this prerequisite, but they can later on in the credit. The proposed guidance steps for option 2 include first selecting the appropriate energy design guide based on the building type. These are the 4 that we discussed earlier for office, retail, school, or healthcare buildings. Then it needs to be confirmed that the envelope, HVAC, service water heating, and lighting designs from the listed standard 90.1-2010 sections are in compliance with requirements. The HVAC and service water heating equipment need to be in compliance with Chapter 4 of the AEDGZ as well. The team can then decide if they are pursuing the optimum energy performance credit and what additional AEDG requirements need to be followed and met. Guidance steps for option 3 include ensuring that all design elements comply with the standard 90.1-2010, and then section 1 of the core performance guide needs to be reviewed to see these requirements. The team also needs to keep in mind scheduling and resource constraints that could come up from additional design meetings and post-construction activity like system verification or ongoing measurements that comes from following option 3. And then early in the design process, the required prescriptive requirements from sections 2 and 3 need to be reviewed and discussed with the team so that they can be designed for. Any alternatives for lighting, HVAC envelope, and water heating systems should be considered. The next step, step 5, is to analyze at least 3 alternative building configurations to maximize the passive reduction of building energy loads. Load calculations need to be performed and documented. Next, the team needs to select the optimal design indicated by these load calculations and review that it complies with Section 2 and then Sections 3.5, 3.9, and 3.10. The last step is to develop a checklist of all the requirements needed to comply with the CPG and review the list with the project team and make sure to include these in the owner's project requirements. The reason that this prerequisite exists is because optimizing the building design based on load reduction and improved mechanical systems early on in the design process, which is done in any of the 3 options that you take, will greatly reduce the energy use of the building and can also lower operating and maintenance costs. Not just that, but it can improve indoor air quality, thermal comfort, and access to daylight, which improves people's health along the way. And here I've shown the required documentation for the 3 different options. You can see that option 2 only requires the Advanced Energy Design Guide compliance tables. I also want to point out some additional notes. To find the project's climate zone and type, you can consult the standard 90.1-2010 Appendix B. They list 8 different climate zones and 3 different climate types. The climate zone and type is required for the 3 different options. And to find the total energy savings for buildings that are undergoing new construction and remodeling, you can use equation 1. Also to note, you can consult the lead reference guide for any energy modeler qualifications and guidance on preparing your preliminary and baseline energy models. Now finally, we are on to the EA Credit 2, Optimize Energy Performance. Thankfully, most of this credit was already completed in the prerequisite. You can see that this credit applies to all categories of the project. And with all except school and healthcare, you're able to earn anywhere from 1 to 18 points. Schools can earn 1 to 16 points, and healthcare can earn 1 to 20 points. The intent of this credit is to increase the energy performance levels above the prerequisite standards. This will reduce environmental and economic harms associated with excessive energy use. To meet this credit requirement, you need to establish an energy performance target measured in EUI in the schematic design phase, which was also discussed during the prerequisite and therefore it should already be done. There are two options for completing this credit. Option 1 is whole building energy simulation, which gives the full range of points in the project categories, or option 2, which is prescriptive compliance with the AEDGs, but this can only earn you anywhere from 1 to 6 points. For option 1, you need to analyze the efficiency measures during the design process and ensure that they go along in the decision-making process, and then you need to focus on load reduction and HVAC system strategies. The potential energy savings and project cost implications that relate to any and all affected systems need to be found. And of course, the prerequisite option 1 needs to be followed so that a percentage reduction in energy use or that percentage increase in the building performance can be found when compared to the baseline model. Percentage improvements and their corresponding points can be seen in this table. 6% in new construction, 4% in major renovation, and 3% improvement in core and shell can get you 1 point for all categories except healthcare, which earns you 3 points, while 50% in new construction, 48% in major renovation, and 47% in core and shell can get you the full 18 points in all categories except schools and healthcare. Healthcare can earn you 20 points, and schools do not offer this. You can earn exemplary performance if you earn at least 54% energy savings in new construction, major renovation, or core and shell projects. Option 2 of this credit requires that option 2 of the prerequisite be used. This is because each option uses the ASHRAE 50% AEDG to improve the energy performance. Implementation and documentation of that Chapter 4 need to be followed as discussed in the prerequisite. And you can earn points for the building envelope opaque or glazing, the interior and/or exterior lighting, and plug loads. Each building type will also have its own specific requirements that pertain to these point categories, and that will be described in the AEDG. Guidance steps for option 1 include reviewing the prerequisite and credit requirements before running the energy simulation and ensuring that an appropriate EUI target has been prepared. If the preliminary model wasn't prepared during the prerequisite, it needs to be developed now. This can be done as mentioned in the prerequisite requirements. Then different potential HVAC systems can be analyzed. Remember to keep updating the energy model throughout the design process so that it matches current construction details and specifications, and then update the final preliminary and baseline models at project completion. Finally, you can determine the energy cost savings of the proposed model compared to the baseline model, and this time you can include any on-site renewable energy systems as an offset to energy costs. Step-by-step guidance for option 2 is to confirm that the HVAC and service water heating requirements meet the AEDG prerequisites that we discussed earlier, and then to determine which of the 6 points will be pursued based on the additional requirements of each AEDG. The reason that this credit exists is the same as why the prerequisite exists. Optimizing the building design early in the design process will greatly reduce the energy use of the building and can also lower operating and maintenance costs, and it can provide better indoor air quality, thermal comfort, and access to daylight, which always improves people's health. I've listed here the different documentation that are required for the 2 different options for your reference. And I know that was really long. Thank you for sticking it through, and good luck on your exam.